Welcome to Atlas Copco Gas and Process IndustREAL Podcast. My name is Candice Wilson and I'm here with Todd Gibbs, Marketing Manager for the Americas for the Atlas Copco Gas and Process Division. Welcome, Todd.
Thank you, Candice. Nice to be here today.
Today, we're talking about CCUS, which is carbon capture, utilization, and storage.
Yep. It seems like there's something on this topic every single day in the news or social media. We're constantly hearing about this.
I know, and I read and I see so much about emissions, net zero, 2050 goals. So many people have things to say and opinions about it, and you actually don't know which is right or wrong.
Well, at the end of the day, we're just talking about the pollution that we're putting into the environment with our everyday activities, right? And I found it very interesting back in 2020 that when people stopped driving as much and traveling as much, within a few weeks, we saw big cities that have had smog problems for years all of a sudden had clear blue skies. We saw the canals in Venice clear up and dolphins coming into the canals that haven't been there in 50, 60 years.
I remember that. But how does that translate to what we're doing today?
Well, so within that little bit of change, those couple of weeks of people not traveling, they started realizing how much of an impact we really are having on our environment, right? So customers wanted to start having greener products available to them. Investors wanted to start investing in companies that were helping the environment. They didn't want constant pollution. So the companies had to start reacting to what customers and investors wanted, and they had to start tracking what they were doing and cleaning up their operations.
And with that, I hear a lot about scope 1, 2, and 3 emissions. Could you elaborate a little bit on that for us?
Right, so for companies to prove that they're doing a greener process, they had to start tracking the emissions that were created from their operations.
Okay, so let's start with scope 1 then.
All right, so scope 1 is what's actually happening. So for example, our factory where we produce the compressors, we have forklifts in our factory driving around running on propane. We have heating systems that are running on natural gas. All of the travel that we do for our business, planes, trains, and automobiles, all of that is within our operation is considered scope 1.
And what about using electricity to run everything?
Well, so that would be covered under the scope 2 emissions. For us, we're fortunate in New York State that we have access to hydroelectric power, wind, solar. So for us, we can actually purchase renewable electricity for all of our operations. So that keeps our scope 2 emissions very low.
Well, that's good news for us then. What about scope 3?
Well, scope 3 is tied to everything else that happens. So getting the minerals out of the ground, bringing parts to our factory. Once the compressor's built, then it has to be packaged up.
We know that Atlas Copco is committed to science-based targets and supporting the reduction of emissions. But what are we doing at Gas and Process, and how are we supporting our customers?
Well, so our philosophy here is to help them reduce first and then capture second. So everything we do to produce our machine, to get it out the door and transport it to their site falls into the scope 3 emissions. I already talked about the use of green electricity, but we're also trying to do more local for local content so that we reduce the CO2 production from the transportation of the machine to their site.
And what about the customer operations?
Well, so the scope 1 operations for them is the processes that they're using. And we can do things like provide them a steam compressor. Right now, they're quite often using a boiler to produce their steam. Well, instead of using a boiler every time, providing a steam compressor allows them to recapture the steam, recycle it. That reduces their use of water, their use of natural gas. If you talk about their scope 2 emissions, now the electricity that they're using, well, that starts off with by having an efficient machine, they're using less power. But that's not the whole story. So over time, operations can change. And we can go in and look at the way their operation has changed and make modifications to our machine to reduce their power consumption. And we found that by doing that they're running the machine more efficiently, and the reduction in electrical usage can actually pay for those upgrades within a few months.
And you mentioned capture second. What does that mean?
Well, so this has to do with the reality of carbon capture, right? So in some cases, you have really high purity streams of CO2 just from the natural production. For example, ethanol, where you get the ethanol and CO2 already separated. That's just the natural outcome of the process. That's not the reality in most cases, though. A lot of times you have small percentages of CO2 mixed with a lot of other gases. Add to that the complexity of where the plant is not necessarily where the CO2 is going to be either used or stored.
That's a lot to unpack, Todd. So let's start with the high purity stream.
Okay, so another example of a high purity stream would be the production of hydrogen. Right now, the most common production of hydrogen is methane cracking. So they use a steam methane reformer and they get the hydrogen and the CO2 stream. But the CO2 still has to be brought up to pipelines level or sequestration level. So that's 2,000 to 2,500 PSI. Now, the way to get it there, what we would recommend is bringing it up to supercritical level with a compressor, so 1,200 to 1,500 PSI range, cooling it to liquid form, and then using a pump to raise it to the rest of the pressure. That's the most energy efficient way to bring it up to the pipelines.
And what about the more challenging applications?
Well, so for many of our customers, what you'll find is they have many point sources of CO2 throughout their facility. All of that needs to be collected and brought to a location where it can be cleaned, and you can remove things like water vapor, NOx, SOx, whatever other things, corrosive elements, or things that don't meet pipeline spec. And then you've got those two things separated, and now the CO2 is ready for the next step.
The next step. So does this mean we're talking about the utilization and storage part of CCUS?
That's correct. And this actually comes with some good news. People might not realize that we've actually been pumping CO2 into the ground for many decades. It's been being used for enhanced oil recovery. So from that perspective, this is not anything new. Now they're looking at storing it into geological formations, and in many cases, pumping it into the ground where the oil and gas originally came out of.
And the utilization part?
So this is a part that I actually find very interesting. We see customer applications where they're using it for food production of synthetic fuels, for feedstocks, for polymer production. So on the food side of it, can be used for creating fertilizer. We see customers that are actually pumping it into greenhouses to help the photosynthesis process for the plants. For synthetic fuels, they can actually combine green hydrogen with CO2 to make synthetic fuels that replace fossil fuels. It's a direct replacement. This helps to decarbonize transportation sector, which is generally very hard to decarbonize. And then also for polymer production. So this helps us move into a true 360 economy where we're no longer pulling oil out of the ground. We're reusing CO2 that we've captured in other areas to produce those polymers and plastics.
So it seems that we're able to address scope 1, 2, and 3 emissions. So does this mean that our customers will be looking at new applications? And do you think this will raise any concerns?
Well, as anything that's perceived as new, there's always concerns that come along with that, right? And our customers are expecting reliable equipment that's going to run for 20 plus years. Well, so some more good news here. The gases and fluids that we're talking about, we've been handling with our equipment for a very long time. We always design our machinery to meet the custom application that it's intended for. So again, what we have always done. We also design our equipment around proven industrial standards like API and ASME. We build into our equipment the ability to run for up to 5 years before maintenance cycles. So all of that aligns with what our customers know from us and is aligned to help our customers for today, tomorrow, and into the future.
With the future in mind, and you mentioned maintenance earlier and how we're able to modify equipment and optimize performance, what other aftermarket solutions do we offer that can ensure reliability for our customers?
Well, I already mentioned the idea of local for local production. In that same sense, our aftermarket team, we feel, should be close to our customers. So we've got a global aftermarket organization. We know our equipment runs 24 hours a day, so do we. So from that sense, we're out there making sure that we are able to provide the service and the parts for that equipment for the next 20 plus years. Just in that frame, we've got equipment that's been running 30 to 40 years. We're still providing service on it. We're still able to provide spare parts 40 years later for that equipment.
Looks exciting. Thank you very much, Todd, and thank you very much for the insightful discussion.